In this episode of Finnogric Machining, it will be the final touches for the rotating mechanism for this rotating welding positioner. There will be a change in the reduction drive. Well, the previous one was a binder, and there is a reason for that, and it's not like bad machining, it's a bad design. And the binding won't go away, it will only become worse. Well, that's one. And then we have to cover the gear somehow so that we keep the possibly the grease and dust apart from each other. Well, that's more than enough for one episode, so let's start with those. Okay, let's see now. Here is the new gear reduction system. It's just 2 gears, and there you go. So, there is a reason for that kind of thing, but let's see first how it runs. First of all, before it runs, I show you it can be turned really easily. Of course, because the reduction is not that much. And then if I plug it in, there it turns, and it's powerful enough. You can hear how it, you can stop it like that if you want. I don't. So, and here it is running. As simple as that. And now, let's unplug it. There you go. Of course, what we need to do here is put a cover here on top so that it protects the gears and makes it so that the gears won't come out from there. There is nothing to hold them in place, just this 10mm small shaft that goes there, and yeah, okay, that's one thing. Then we need to protect this big gear somehow to keep the dust away from there. What I have decided to use is this. This is some rubber tube about this. You can see the size. And when I split it, like this one has been split, and then when I put it around here, it slides still quite freely there, like that. And then I just put it all around there, and at these places where it meets this thing, I don't know how to do this, but I'm sure I figure it out. Okay, well, that's one. And then about okay. So this is the old gear. It's there is a very good reduction ratio in this one, but that's it. Other than that, it's not a usable item actually. The more power you want to take out from it, the more it tries to bind. And the reason is so that because this gear, it's a ring, and a very thin ring actually. It means that when it rotates, it pushes, at some point it pushes this ring out from a point and deforms it. And when it's deformed, it binds from the sides. And the more you load it, the more it binds. And at some point it becomes so that the binding becomes more than the force required to bind. So, well, it's positive feedback, and that's not very good. It really binds tightly. Yeah, so it's a very good mechanical item. Everything was all right, and it was nice to do this, and it looks nice, and whatever. But it's not a usable item. This is like bonk. Yeah, I will put some pictures about bonk for you. So, well, that's it. And then now this piece of rubber, it's the same tube you saw there. The next step is that I have wrapped it as a coil here, and now I will also cover it with this stuff. And then I will put it into oven for well 150 degrees Celsius, and let it sit there for 1 hour. And then when I take it out, I let it cool. I assume it will take at least some of this curvature with it from the oven, hopefully. This helps when I wrap it around the thing, so it's already like curved. And then of course I split it from the inside. Well, this is just ordinary aluminum foil. Let's see. I tried. Wow. There you are. Okay, here we are in my kitchen. So let's see now. This is about 150 degrees. Well, and then we take which is this? Okay. Yeah. Okay. Then we put this inside here. And 1 hour. Yeah. I detached this thing from the controller box, so it's easier to do this. And well, now you can see we have it like this. So this gear, we need to make one modification to this one. We need to drill a few holes, maybe 2 or 3 holes, so that the grease goes into the bearing surface. So that's one. Another thing is here on the top we need a cover. Okay, let's take from one. Oh yeah, this is good. It's 5mm thick steel. This is from some device I have dismantled. It contains a lot of stuff like this, small pieces which I really like. Good quality steel. So yeah, okay. So there will be 2 screws. It's just a round plate which has a cut off for this thing, so that it doesn't, so that it barely goes there but doesn't touch. Okay, I think I can do this. Oh yeah, I will make it round first in the lathe, and there will be a grease fitting in the middle. There is a 0.2mm gap between this surface and that surface, so this is lower. So when you push grease there, it will go into the needed places. Okay. Okay, while that sausage is still baking in the oven, we have time to make this hole into there. The purpose of this hole is to deliver grease to the bearing surface there in the middle. So when the gears rotate, they push the grease into that hole. I have tested this principle, whatever. I have tested this and it works. The concept is alright, it works. So, well, let's see. First of all, the speed of the drill. It must be quite high. About 2000 RPM, no, well, 1000. And now, let's see if the alignment of the drill is alright. I put it so that the flutes are sideways, and then I see, oh yeah, it's moving a little bit. So that it's exactly in the middle of the, yeah, it is now. And this is a very delicate operation. You have to be careful at first because it might grab on the sides. So here we go. No, the speed is not alright. That's okay now. I think we got it. Okay, then we can start drilling really. Oh yeah, this is a 2mm drill. Goes like into butter, really. But okay, we are already on the bronze bearing, I can see from the color of the chips. Okay, it's true. Oh, no explosions. Good. Now, while that sausage is still baking in the oven, so let's start making this round plate from this. So, well, the diameter of the plate should be 71 millimeters. Okay, so this is actually 71. And now when I divide this by 2, it will be 35.5 about. But since I want to leave something to, I will do this, by the way, in the lathe. So I leave something here, maybe to work with. So let's say 40 millimeters. So this should be 80. It is. Oh man. A little bit less, please. Oh well, yeah. Okay, 40. Then we can do it like this. Let's write one line there. That was 40, and from the other side, well, that's in the middle, about. And then I will about in the middle. Let's see that this is okay. Yeah, go. Well, it's not in the middle, but this is business. So it's on the side. Oh man. Let's put it there. Okay, now it's okay. And one more time. There you go. And then I scribe a line with this. Let's see about oh yeah, okay. Let's see now. Okay, and that I will, the rest I will cut away with an angle grinder. And yeah, this has some copper coating on it. Oh man. Okay. So let's take this sausage out of the oven. Well, bon appetit. Now, this thing is still cooling down. It's a little bit warm. I let it cool down properly before I open it. This is just to ensure that it adopts at least some of this shape. Let's see, but before that, let's go out and angle grind this thing away. Okay, so let's now unravel this, Christmas present and see how much did we adapt the form I intended it to adapt. Oh, it's a little bit warm. Yeah, it did. Yeah, it did adopt the form. So now it's it's like this. Very good. I'm pretty sure it will straighten out a little bit during some time, but yeah, it adapted it quite well. Good. Okay. Now I'm going to drill and tap an M8 hole in the center of this, and there will be a crease fitting like this there in the center. Finally, first we put a bolt there, but that will be the final inhabitant of this. And now I'm centering the drill into the hole we made, or the dent we made there. I'm just pushing the drill into the dent, and when it doesn't move sideways, then I know it's in the center. And then I do this direction as well. I put it intentionally to the side so you can see how the tip of the drill moves. Now it's not moving anymore. And then our speed. Actually this drill press doesn't have a scale for the speeds, but well, you can estimate. Well, that's about alright for this type of material and drill. So now some cutting oil, and let's, oh yeah, this is 6.5 millimeters, which should be, well, I should check it. No, well, it should be the tapping size for M8. Here, M8, 6.8. But the minor diameter is 6.466. Well, we can do this with 6.5, albeit the tap will be a little bit tight. Okay, but that's alright. It's so thin material, so it's a very good thing to have more, so the threads are deeper. There you are. And then a little bit of a chamfer there. That's okay. And now we go. There you are. Huh. Okay. Yeah, it's a little bit tight, as I estimated it to be. Well, there you are. Done. Didn't want to come out. Oh yeah, that's it. Well, these are the threads. If you put them back there, you have a perfect round hole. Okay, now starting to turn this workpiece around workpiece. A new bolt. Tighten it fully, maybe a little bit more, but let's see. This should now be straight, and it's straight enough. Good. Let's tighten this here as well. Well, now it's tight. Okay. Then about there, I believe, and then and now what I will do, I will loosen this a little bit, just a little bit, so I can push it. Yeah, I can feel now the drag in the chuck, so it's fully against the surfaces of the chuck. I loosen it again so I can tighten it fully. Yeah. Yeah. Okay. Feels very solid. Okay, and now what will be, I think I will be using this one. This is a tool I soldered myself there. It's a very good one. Very good for roughing. And the reason why it's very good for roughing is that it doesn't make long chips. Well, of course, now that I said it, it will make. But usually it doesn't make long chips. Well, we need to set the stop so that we don't run into the jaws. That's always a good practice to see that we don't run into the jaws. That's probably over the point of, yeah. This will be pounding quite a bit at the beginning, so therefore all okay. And now let's tighten this. Oh, the tailstock. I have to be careful with that one so I don't use. It traveled back a little bit because I stumbled into it. So now, and this one. Yeah. Okay. I can fine adjust it by the compound. Okay, there you are. And then let's look for the nearest point. That's near, quite near. Oh, there is a lot of deviation there. Our chamfer. So this is a dividing head which is not used as a dividing head this time. It's just used as a chuck so that I can drill two 6mm holes into this workpiece. And these will be around here and there. And they are like 25mm from the center. And well, let's see now. The relative distance of these holes is really critical. Critical down to 500s. And then, well, That's it. So now what I'm doing, I'm adjusting, this is a little bit flexible. So I can see if it doesn't go exactly on the center of the hole. So let's see now where we are. I think there you are. So I lock the Y, lock the Z, and then I change here a 6mm drill. I can tighten it here. Now we move 25mm to some direction, so it's 4 turns plus 1mm. So 1, 2, 3, 4 and 1mm. Then I think we need rockle here. High gear, like that. And then let's see about the speed. That's about right. And we drill our first hole. Millimeters, 20 is 5 turns. No, that's the wrong place. That's totally wrong. Man! So now it's like 4 turns. We need 1 turn more, I believe. 24. It's 6 turns. Ah, scheiße. And that's the original 0 there, right? Right. 24 divided by 4 is 6 turns. So 1, 2, 3, 4, 5, 6, and then 1mm. Okay, now it's 25mm. Oh man, I need to learn how to calculate. Now the place looks correct. It's true. Oh. Oh yeah. Holes are there. So I decided to file it. And this is really, I already started this and this is almost ready. And there is a black marking about here. Okay, I need to file a little bit more this side as well. This goes, with a good file, this goes really fast. well, there really isn't any easy way to cut this. So, and it has to be split on the back side here. So I will need something like 1.5 turns here. So I already started, I tried different methods, and the best one I could come by is just to cut it like this. 5 millimeters at a time. Yeah, this needs a really sharp knife. So this is the one we are using now. Here it is, the rubber boot for this. It certainly fits there. There will be some difficulties with this one, especially because it has, there is a, how would I say it? It has friction. You can rotate it a little bit like this, but there is rotation, friction. And somehow I feel it should have a support around it, so that it doesn't, if you draw from this and it bites, and that's not a good thing. So it should be pushing this side as well. So there must be some, maybe 2 millimeter steel rim around here. That should fix this issue. And this certainly has some benefits. First of all, it's not too bad looking. The footprint is really small. If you compare this to a complete housing, then it protects the gear quite well, actually, and and it contains the crease there where it should be. Now I just need to figure out how to put it here. This will not happen today, and not in this episode. Okay, so in the next episode of Finnugric Machining, I will be probably making the rim, and then start making, there is a, you cannot see it, oh man, let's push this a little bit, yeah, now you can see it. That one, this is for the foot. There will be about this long 40 millimeter steel pin, about this long steel pin, which then is used to rotate the thing around it. And then this pin will be on a foot thing, which then will actually support the whole thing. So you can tilt it and then you can rotate it, the whole thing. That helps when you, it helps or doesn't help, I don't know. It's a foot, it helps quite a lot. So that's a thing that I have to make at some point, but not today. So that is probably what you will be seeing in the next episode. Till then, Bye!